Hi class, I'm Dr. Elizabeth Kiriakou, and up until now we have been solving problems on forces and moments, and we should all know our equations for equilibrium, and hopefully you've drawn lots of free body diagrams. In this lecture we will build upon the knowledge and learn how to analyse engineering structures. So engineering structures can be classified as trusses, frames and machines, and these structures are used to support and transfer forces acting on a system. To design any engineering structure, a truss force analysis must be performed, and trusses are used in the design of bridges, roofs, aircraft, chassis. So first question is, what's a truss? A truss is a framework composed of members that are joined together at their ends to form a rigid structure. So let's take a look at this. So here we have truss analysis, and a typical truss will look like this. So here's our members that I'm drawing right now. And our truss needs to be supported at the ends. So here we'll have a pin joint and a roller. So when I look at this problem, first thing I need to know is to find these reaction forces. So these are my reaction forces. And I'll have a load, and I'll call that F1. So I'll draw an axis up here, and that's my X and my Y. And on my pin joint, I'll have a horizontal component and a vertical component, and on the roller, I'll have a vertical component. So to solve any problem, let's find our reaction forces. So we've done this before. How am I going to solve the pin and the roller? I'm going to use my equations for equilibrium. So some of the forces in the X direction equals 0. Some of the forces in the Y direction equals 0. And some of the moments around a point will equal 0. Okay, so these here are called members, all of this. And I want to find what the force is in the member. And here are my joints. So today we're going to understand how to determine the force in each of these members in the truss, and some members are going to be load bearing while others are just for structural stability. The content of this lecture is firstly determine the force in each member, and this can be done in two ways. We have the method of joints or the method of sections, and secondly to determine the zero force members of a truss, and finally to analyse the forces acting on the members of the frame of a machine where we have pin connected joints. So first of all, we've got method of joints, and secondly, my pen works, we have method of sections. And finally, we'll look at zero force members. So what else do we need to think about? With our members here, they will be either in tension or in compression. So if I take a member, and here we have tension, this is my member. If my system is in tension, then I'm going away. I'm pulling it apart. And if I'm in compression, I am pushing towards the member. So how do we solve one of these problems? If I take this joint here and I redraw it, so I'm going to take, we'll call this point B. So if I take joint B theta. That's almost a free body diagram. I can put a little axes on this. There's my free body diagram. And what I'm going to do is I'm going to assume that all my members are in tension. Which means I'm going away from the joint. Now I can resolve these forces in horizontal and vertical components. So this force will have a x and a y component. And I can use my equations of equilibrium and say some of the forces in the x direction equals 0, and some of the forces in the y direction equals 0. So in the next video, we will take a look at method of joints, and subsequent video will be method of section, and then following on with zero force members.